Hello there. So I did a video the other day on the Sentat on the Raspberry Pi, and we put it into Python, and we looked at importing. Excuse me. We looked at importing libraries to basically make these 48 LEDs. So they've just gone out. You can see them a bit clearer now. Make them change color, and basically to control them through using Pi library, the Senset library. I was mindful, however, that I didn't really kind of give much of a chat about what it actually does, how it works. If you're going to invest in it, and I kind of recommend, I suppose, that you do, just because this is my Raspberry Pi. I'm not sponsored by Raspberry Pi. There's my coaster for my drink. I do recommend it because, as I said to you, I think in the last video, that whereas things like microbit would possibly be cheaper, but they don't offer the functionality that the Raspberry Pi does. Raspberry Pi is a Linux operating system. It's basically a microcomputer. You can, listen to your music on it. You can watch YouTube videos on it. You can code on it. You can play games on it. You can do just about anything with this thing. And if you're not familiar with the Pi, I'm going to hold it up. You can see how small it is. It's really quite something. It was designed for educational purposes, and they're tiny. I mean, I've got mine in a little kind of rainbow case there. This is a Pi 4. Will get me with my Pi 4, and they're pretty much out of stock everywhere. I don't know. I'm a little bit obsessed with these guys. I think they're amazing. I'm very, I like them a lot for educate. They were designed for education, but I really like them for school life. And you can never have too many. I probably have got too many, but I don't think you can have too many. So I was looking to maybe stock up on a few more, and they're out of stock everywhere. But Pi 3 would do the same. Pi 4 just has a bit more oomph to it, a bit more RAM, a bit more clock speed and so on. But certainly for kind of things I do, it's, 3 is great. So basically the Senset here sits on the GPIO pins here. Like you can see the general purpose input output pins. It literally slots in, and then at the bottom here you can see I've fastened a couple of screws there just to kind of help it sit nice and snug on the board. So if I undid them screws and took it off, then you could see the top of the Pi and the processor, and just kind of printed circuit board, and that's quite nice to look at for some lesson learning bits and pieces. So I'll just try and show you some bits here and sort of tell you what it does. Down here then, if I can kind of zoom in, I did say before I'm not much of an influencer, and you can see I'm already struggling. Down here at the front, in the bottom kind of right of the Senset, if I put my finger on it, it might be easier to see. There's a little joystick, and if you can hear the click, probably can't. But you can push that up. It's a joystick effectively, so no introduction to the gamers out there. You can push it up, you can push it down, left and right, and we'll be using that in a minute with the code. But you can also see here with the, I think I said in the previous video again, that this effectively turns your Raspberry Pi, which is a pretty versatile bit of kit, as I've just said, into effectively a kind of a microbit. It's packed full of sensors, and these 48 LEDs, as we saw in the last video, is for all intents and purposes an output device. It will show words, it will show pictures, it will show variables, taking an input into the Pi through the sensors, and then output a value, and we'll see that working in a second, or as part of this video. And here are the sensors. So these are built into the microbit, but on here then, so you've got an accelerometer sensor there, which obviously detects movement, and you've got gyro. So if I was to rotate it, push it forward, or drop it, and not drop it so much, but drop the nose forward, or drop the nose, or drop it back, so it's sort of tail down, then it will show a reading. And I know we did a lesson in class on kind of aircraft sensors of warning the pilot if the z-axis, sorry, forgive me, the y-axis, which is the lift, the up. If you think about your standard bar graphs in maths, your y-axis is the up. So if your y-axis is too volatile, if it breaches a certain tolerance, then maybe send a warning message to the pilot, or to straighten the plane, or that the plane's in danger. You can also see their pressure sensor, Once again, I'll try and zoom in. Pressure, you've got humidity as well there, like temperature and humidity. So it's pretty cool. You can move the Pi, as we saw there with the accelerometer, and it will give you a reading. You can also use the joystick, or you can use Scratch. And that's kind of what we're going to do now. We're going to employ a Scratch extension to the code. We used Python last time. Python's a bit more fun, it's a bit more real world. Scratch obviously is much quicker and it's much more colourful, and the block code programming, it's, you know, it's very easy in quotes to get a result. Whether you get the result you want is a different argument, different, you know, different debate. It's cool to use Scratch. So this video we're going to use that, and to see how a combination of Scratch extension and this cool piece of, or these two cool bits of kit, we can hopefully get some responses, get some outputs. Okay, so I'm in Scratch. I hope you're not getting that rain. I'm just recording up in the spare room here, and good old Irish weather. It's hammering down. It's April showers, I think it's called. It's probably going to be May and June and July showers if I know Ireland. But anyway, look, we're in Scratch, just a traditional Scratch software. No frills, nothing special. Obviously, I'm in Raspberry Pi. I'm not in Windows. I'm on my Pi, and the cool, clever hipsters at MIT had a look at Scratch, I think for Scratch 3, and changed the options slightly for the code blocks, palettes, whatever you call them here: motion, looks, sound, events, control, sensing, operators, obviously variables. A lot of these are pretty standard kind of things you would use in coding, whether you're using Java or Python or whatever. Certainly events and variables and control and loops and so on. So I think they kept them in, but what they did do, which was quite clever, I suppose, I don't know whether it was using usage metrics or whether it was feedback from users or just general good thinking, they added a extension option at the bottom here. And if you click on that, it brings up this. And what it does is it allows you to kind of extend effectively your Scratch palettes. So music, obviously you can use that to do your drumming and your guitar sounds and your keyboards and that. You've got pen, which we use quite a lot in class to have events, moving the mouse around. You can draw things. Video sensing, so you can use that for your gaming perhaps. Again, in class we've done it where your video camera or your webcam or whatever, if you have one in your laptops, can detect movement, so you can sort of be bashing critters, aliens can be falling down, you can be using your hands to bash them back. So it's kind of similar to the PlayStation Move. It's quite nice to make a game like that. If you've ever used a PlayStation Move, you wave your arms around and smash bugs and so on and so forth. Text to speech, which is pretty obvious. You type in things and it says it back to you again. You need speakers. Translate, I think that's fairly self-explanatory. Makey, so obviously using the pins and using crocodile clips and that to kind of make to extend things, engineer systems and so on. And then down here, the bottom 3 here is where we want to be. So you've got your Raspberry Pi GPIO, which is this effectively what I said, was where the SenseHat snaps in. So you can use that to get the code for that to kind of turn these on and to make them active. But we've actually got an extension for the SenseHat here, which is brilliant. That's what we want. And then there's some simple electronics ones there as well. So just, I don't know if you're aware of this, but just be mindful of this, that it's very easy to extend your Pi out. Extend out your Scratch to go beyond just playing games, making games, and even though that's popular, I know, and huge fun, it's very easy to extend it. So I've clicked on this then. So if we click on this, we get this down here then, this new, under my blocks, we get this new code block palette, if you want, or whatever you call it. And then the code attached to this Raspberry Pi SenseHat here at the top is all related then to that that to the sensor on the Pi. So effectively this is like when we looked at the video before with the Python, importing sensat and using the functions within that library, if you remember, like display color and pixel color and write message and sleep and you know, to delay things, to slow things down. I think we did that with the flashing hearts and the rainbow. So that this effectively is that, I suppose, you know, and to an easier degree, because obviously this is drop and drag, but to an equally kind of comprehensive degree. Now, a couple of things I'll say here is display text. Hello, we'll be looking at that in a minute. In fact, we've got it here in front of us. But you've got display character, you've got display, this is quite nice, you can display a picture. Now I think that's a Raspberry Pi, but if you click on this and then you've got here the blank one, you can then say what you want it to be, so you can start to build your own little picture. So again, with, if you're familiar with microbits, there's the option to do this exact thing, and I know I get my class to build emojis and build little displays. Okay, now that takes time, like all animation, that takes time. Just drag that back over there, get rid of that. But that's a nice way if you want to turn on individual lights and do like a little firework display or a little something, a little loading screen or a little something, just to get something nice and visual for the user to look at. You've got display sprite. Now I've used that, it isn't amazing, but we could maybe use that. That's going to display the sprite, and the sprite currently is Scratchy. I've just used Scratchy, the kind of default cat, the Scratch logo. Display stage, I think we know what that is. That's whatever, obviously it's white. I haven't put display, clear display, you know, obviously clear the screen, get rid of everything. So this is set color too. So this is your text color. And if you click on this, I'm sure again people in Scratch, if you've used it before, you're well familiar. Turn your brightness up, turn your saturation up, and then you can then use the wheel at the top to, or the slider at the top to pick a color. Now that's exactly the same as doing what we did in Python again with the hex references. I don't know if you remember the three numbers, the 255s. Obviously with that you need to look up them numbers on the internet and find out what red is, what green is, what yellow is. This is effectively doing the same, just easier. So you can really pick that. If you want a green but not quite as dark, you might want it a bit more, sorry I'm a bit thingy there, you might want that kind of green, like a lime green rather than the dark green. You see it getting slightly darker there, and blues. It's just a nicer way of doing something quicker. Alright, and I know speed sometimes with people is everything. You've got set background there, so it's a similar thing. You can set your background to a nice colour. You've got set pixel, so this is where you can now program your pixels. Remember there's 48 pixels on the 48 individual little lights on the Sense app, so you can click here and you can pick which one you want. So it's kind of like battleships. So with the counting of the list, if you want, with the counting of the position of the pixels, it's very much like a list in Python, where it starts counting from 0. So there are 8 here, even though it stops at 7. Alright, so just be mindful of that, that if you're talking about the 0, that doesn't mean it's switched off, that means it's the first position in the X coordinate. So it's going to be this one over here, it's going to be the far side one. Okay, same with the Y. Alright, so just be mindful of that. If you're using that, you can, you know, build up a nice display. Set rotation to 0 degrees. I'm not going to go through all of these because we're going to be using some. But worth saying down here though is some great stuff. Temperature, you've got temperature, I'll bring these over, you can see them. Temperature, pressure. Okay, so I've just clicked on that bot in error and it's come up with a value, which is what Scratch does. What's brilliant about it. Humidity, you've got roll, you've got pitch, okay, and you've got yaw. Now these are all built in to them sensors I showed you in the previous video, so you don't have to worry about these. It's going to get an input from the device and present it back to you as an output to the sense hat. It's through them pixels. Okay, so it's doing all the heavy lifting. All you need to do is to write the code. Okay, so I'll just drop the map back there then so we can see what's going on. Let's think then. So we've got let's look at this then. So very simple code. When H key is pressed, so this is an event on my keyboard. When I press the H key on my keyboard, do what? So it's going to, on the sense hat, not on Scratch. It's not this. I'm not using a looks say. If I use that, the cat would say it. I'm not using the screen. I'm using the SenseAct to display the text "Hello World." Okay. So if I press H on my keyboard, then I'm looking at my SenseAct and it's saying "Hello World." Now you can't see that because of, you know, we said before about I'm not an influencer. I don't have 1,000 cameras everywhere, but it should have been playing beside. As I said that, it should have been playing beside because I captured that on my phone, and hopefully you've seen that. Okay, so what we're going to do then is we're going to just scroll down here a minute, and we are going to look at a slightly more advanced piece of code, just seeing how the Scratch and the Sprite and the SenseAct can talk together. So this time Scratch comes into play. This time when I press the space key, the Scratch is going to say to screen, not through the speakers, "Hello, my name is Scratchy" for 2 seconds, so he's going to say that. Then he's saying, "I'm talking via the SenseAct" for 2 seconds, and then using the sensing block, using the sensing code, it's going to ask for "what's your name," and then it's going to sit on the screen and wait. Okay, I then type in my name through the keyboard. Okay, it then reaches out to and so ask "what is your name" and wait until I type that in. It then reaches out to it then stores that value that I type in, that variable, if you want, for want of a better word, variable. So my name, and then I could do my children and their names are different to mine, and so, you know, a variable just changes. So whatever you type in, it's going to store that in this called answer. Okay, so just leaving that there to explain in a minute. Then it's going to set the background color of the SenseAct to blue. Then it's going to set the text color of the SenseAct, the text color. It doesn't say text there, it probably should, but it doesn't, to yellow. So they're nice colors that work well. And then it's going to display on the SenseAct then, not this anymore, not say it to screen. On the SenseAct, it's going to say, "Well, hello, join answer." So whatever you type in here, "Well, hello." If I typed in sausages, "What's your name?" "My name's Sausages." "Well, hello, Sausages. Lovely to meet you." I spelled lovely wrong. I've just realised there. It's a bit embarrassing. There you go. Oh, I've deleted the wrong letter. "Lovely to meet you." Okay, "lovely to meet you." That's better. Lovely to meet you. "Well, hello, Sausages. Lovely to meet you." Go around again. "What's your name?" "It's Pizza." "Well, hello, Pizza. Lovely to meet you." And so on, and that's going to be displayed on the SenseAct. All right, so if I do that, then let's do this. Let's make this big. Let's push space on here, and he should say, "Hello, my name is Scratchy. I'm talking via the SenseAct. What is your name?" And you can see down the bottom there, there's a little slot for me to type something in. So I'm going to do that. I'm going to type in my name. Let's put something long in, and let's put in sausages so you can see it coming up on the screen. Okay, so sausages, yeah, that came up there. So when I click on this now, I don't know if you can see this. Well, it's going a bit crazy. Sausages, lovely to meet you. Sorry about the screen being a bit dodgy and a bit flashy and everything. I'm trying to keep it nice, but it's not easy. Okay, so that works nice. So that's that one there then. So what else do I have for you? So let's just stop that and go back to this. So that's now that's nice piece of code, very simple, and you know, you could say so what, but it's just the code talk. It's effectively Scratch taking an input from the screen, you typing in sausages or your name, and then it displaying it, talking then back to the SenseAct and displaying that. That's nice. Okay, now then, I'm going to pause the video. I've just realised I need something for this. I'm going to change the temperature in the room, and the way I'm going to do that is for hairdryer. Those that know me know hairdryers and me aren't good bedfellows. Not needed one in 2 decades, but I need to get one. So basically, when I push up on my key on my joystick, it's going to show the temperature, and I'm going to run a bit of heat over the Pi, and you can see, or a bit of cold air actually over the pie, I don't want to damage it, and you can see that changing. Okay, so I'm going to pause this and then we will be back in 2 seconds. Hey, okay, so we're back here. Oh, let's get rid of that. Sorry, a bit amateurish. We're back here now, and I've got my hairdryer. Nicked it from my wife's or my bedroom. So this is very simple, and this would need some playing with, I suppose, if you were using it as part of a bigger hypothesis or project. I know that the Sense Hat is used extensively with AstroPi projects. It's up in space. It could be measuring air temperature or temperature outside the. I don't know. I'm not going to start flannelling and sound out my depth because I probably already am. But it's just a good way of the sensors within the Sense Hat could take a snapshot of the environmental factor of this case, in this situation, temperature. Okay, so what I'm going to do is I am going to film the current temperature in the room. It's a cold room actually, heat's off, I'm upstairs, and so if I do this, then I turn that on. And if I click up then on the joystick, so if we do that, let's click up on the joystick, then we should get the current temperature in the room. So we look at the 29.56 in the room currently. So let's try this then. Let's give this a blast with the whole hairdryer and see what goes. So you may lose me here. Hopefully then there should be a different reading on it. So now it's saying 17.34. So I mean, we blasted by that, so it's 18 now. Obviously the hair dries off, so it's starting to pick back up. If I was to do it again, 19. So you can see how it's going up every time there, just gradually. So that's pretty cool, that's nice, that's working well. So basically the temperature in the room was 20 something, it's probably going, yep, 20, now it's going up again, as expected. So it's going a bit flickery again now, it's hard to, going back to kind of normalising. 21, yeah, so it's sneaking back up to as it should be, but if we give it a blast of cold air, obviously I didn't use the hot air on the pie for fear of damaging it, it goes down. So that would be nice if it was outside, if you're doing some science experiments at school or something, you wanted to test the temperature dropping over a certain amount of time, that could be great, something like that would be great. Alright then, so the other piece of code that I wrote, again, mad simple, but it would need work, but it's, this time we kind of push the joystick down, but when we do, it's going to give us the display, it's going to read the roll, it's going to, using, I guess, the accelerometer sensor within the Sense Hat, it's going to give the roll degree. It's going to take a position of the hat, whether it's straight on the table, whether it's flat on a table, whether it's turning lifting up, nose up, whether it's nose down. Now this is just based on, again, this is very simple. You need to play around with this if you're doing something sciencey, but it's basically built on a 360 degree circle, obviously like a roll. So if I, for example, if I take a reading of it laying on the table, which we'll do now, it should say, if I just push the down arrow on the, sorry, I'm finding this tricky, push the down arrow, it's saying 1.9, which would work, right, because it's laying flat. Now if I lift it the screen might flicker, because the HDMI I'm using is a bit on the ropey side, so I'm kind of lifting it now. I'm laying it on the table there flat, but I'm kind of lifting it now into the air and tilting it up, so I'm expecting that to go up. So let's see, 38.83. okay, So let's see then, let's turn it up even more. So I'm almost, I don't know, I'd say 70 maybe, or 54 even, that was a little bit out. Okay, and I'm sure you're not really getting this, but now I'm almost vertical, now I'm almost 90. And that's 79, so I'm obviously not 90. And now I'm pretty much, so now I'm 83, I'm pretty straight then with the, so if I start to level out again, 28, and then I level out again, 7, so I'm almost flat on the table. So if I start to nose down, get over there so I can see what's happening. 3, 2, 6, so you can see then that's the circle. So you get you an idea if that's the kind of, that's where I'm at, this is what's happening. Okay, so I'm nosing down, so if I really nose down, I don't know if I'm going to get this, how good this is going to be. 3, 6, 1. So I'm in danger, I don't know, I'm thinking here, I did this with the microbit with the class, of, you know, safe landing of an aircraft. And if it's, you know, flat on the runway, then we're cool, because obviously we're safe on the runway, hopefully anyway, not moving, then we're 1. So you could be writing a little bit of code there to send a message to the cockpit or to, you know, engineers or whatever, I don't know, pilots, well I guess you'd hope they're in the cockpit, but you know, to say you know, if the roll level is above 70 degrees, so if you're nosing up, the plane's nosing up, it's in danger of stalling, based on kind of physics. And if you're nose down, if you're facing the tarmac, then, you know, there's another problem there, I would suggest. So you could maybe take 2 tolerances and say, you know, if it's above this, then send a message, and if it's below a certain tolerance, then send a message that way as well. That would be good for, you know, air safety. Again, I say it's not gonna, you're not gonna get any contracts with Boeing, and it'll be a lot more comprehensive with that with them. But it would be, you know, it'd be a good little classroom activity perhaps, and you could use it in, again, maybe something to do with AstroPi, something to do with science within cross-curricular, something to do with that. So then in this very short video then, maybe not as short as you'd like it to be, some of us like it to be, we've used the joystick to push down then to get the roll settings of the SenseApp. We've pushed the joystick up to get the temperature in the room, and then we blew some cold air on it using a hairdryer to get a different, to get a sense of the input changing as the environment changes. We used a little bit of simple code here for our little sprite to say his name and to ask your name, and then we sent the answer to the SenseApp and we displayed it on the SenseApp, and then we did an extremely easy bit of code to just click H, just an event, click H on your keyboard, and the hello world appears on the SenseApp. So very simple, very quick, loads more it can do. You can shake it like you can a microbit. You can, there's when shaken here, like say, I'm assuming people are familiar with microbits. There's all manner of stuff. Just play around and enjoy, have fun, because it is a great bit of kit. Thank you very much for watching. You can get hold of me on tinytext.ire@gmail.com if you have any questions or any suggestions. Thank you again. See you soon. Have a lovely day.